Now, as you look at part B, in this section, it's tempting to say, oh, this is another one of those log equations, so I'm going to play exactly the same game that we did in A when we do B. The problem is that doesn't work. In this section, in section 6.6, each one of these problems is just a little bit different than the previous problem. And because it's different, that means the technique that you're going to use to solve it is going to be different as well. So you can't look at these problems and say, oh, this is going to be exactly the same as A, because in fact, it's not. So it's a logarithmic equation again, because we have logs all over the place, but it's different than A because of where the logs are. So back in A, we had a log on the left-hand side and we had a log on the right-hand side. This time, though, I have two different logs on the left-hand side and then just a number on the right-hand side. The fact that I have a number running around makes this problem significantly different than what we were looking at in part A. So the question then becomes, well, okay, how do we do this problem then? So I can't play the same game that I did in A because I don't have a log on the right-hand side. So I have to think about other things that we've done. Well, if you go back to our previous section, section 6.5, think about the fact that we have two little logs on this left-hand side. If I have two little logs, I can possibly bring those two little logs together using one of those properties of logs from section 6.5. So let's see if we can make that happen. So I have a log of somebody plus a log of somebody, and I do have the same base on both of those logs. So now, thinking back to section 6.5, I know that there's a connection between addition and multiplication. So when I rewrite this as the multiplication version, remember I'm only going to write down the log once for that version involving multiplication. So it's going to be log base 4 of the x from the first piece times the x minus 3 from the second piece, and that's going to equal 1. Even by doing that, I still haven't gotten this equation, so it looks exactly the same as part A. I don't have a log on the right-hand side. So I can't use that same rule associated with the one-to-oneness of logarithmic functions to drop the logs. So what I have to do then is think about the fact that I have other rules and other thoughts that we've talked about, and I have to think about the fact that every logarithmic equation can be written as an equivalent exponential equation, and that's the idea that will allow me to finish this problem. So remember that process of equivalent statements. Every logarithmic equation has an equivalent exponential statement behind the scenes. So the process we used on that was that the base of the log was going to be the base of the exponential. So the base of the log here is 4. So the base of the exponential is going to be 4. Logs are exponents. So that means then that we have an exponent of 1. And that then ends up being the result that we have inside the x times the x minus 3. So 4 to the first power is equal to x times the quantity x minus 3. Well, this is actually a quadratic equation. So let's go ahead and use some of our quadratic equation ideas and see what we can do. Now I'm going to start by distributing the x on the right-hand side. X times x is x squared. X times negative 3 is going to be negative 3x. Then, now that I have that piece, I know that this 4 is going to have to go over to that right-hand side as well in order to move forward with my quadratic ideas. So I'm going to subtract 4 from both sides, leaving me a 0 on the left. So I now have 0 is equal to x squared minus 3x minus 4. Again, we have lots of different quadratic solution techniques. You could use any of them that you feel like. I'm going to see if I can use the zero factor property. The right-hand side is factorable, so that means I can go ahead and move forward with factoring. So let's see if I can find two numbers that multiply together to give me negative 4 and add together to give me negative 3. Looks like x minus 4 and x plus 1 will do what we need. Set each one of those equal to 0 and solve. We're going to get an x value of positive 4. We're also going to get an x value of negative 1. Now, it is tempting at this point then to box both of those and say we're done with this problem. X equals 4 is a solution, x equals negative 1 is a solution. However, remember again, we started with a logarithmic equation. And with logarithmic equations, there's the possibility that you're going to have extraneous solutions. So we always need to do that double check step and see if these things are going to cause us any issues. So let's go ahead and plug in this x value of 4 and see what happens. So we have log base 4 of x, and if I plug in a 4 there, that's perfectly acceptable. I can take the log of 4 because 4 is a positive number. Let's check out the next one. I'll plug in 4 here. Log base 4 of 4 minus 3. Well, 4 minus 3 is a positive 1. Positive 1, once again, positive number, I can do that as well. So this is a perfectly acceptable piece. This is a perfectly acceptable piece. 4 is a solution then. So nothing wrong with 4. Well, let's try the other one. X equals negative 1. Now, sometimes people say, oh, x itself is already negative. And because x is negative, we're going to have to exclude that. Well, it's not really how this works. It's only going to be excluded if it makes one of our arguments negative. So it is possible to have an x value that's negative, but it won't make one of your arguments negative. So you always have to ask yourself, what will this x value do to the argument? And let the arguments tell you whether you're going to exclude somebody. So in this problem, we have log base 4 of x, and if I plug in that x value of negative 1, right away, that's a problem. So in this case, because my first log simply has an argument of x, it is a problem that my x is negative. So I can't take the log of a negative number. I can't use this negative 1. So at a minimum, I need to come down and cross off that negative 1. But again, your author likes to come in and say, let's be extra descriptive about the fact that our negative 1 didn't work and 4 is the only one that works. And he always likes to come in and just write this as a solution set. And that's his way of saying, I went through the process of solving and I went through the process of checking, and 4 is the only thing that truly is a solution. So I'll write down the solution set and say that the solution set is the set that contains the number 4.